my programming engineers. Welcome back once more to this drive course. And today we're going to be looking into a very quick topic because we had already analyzed it in a previous video, which is acceleration and deceleration for our motor. Now, what units are we going to use in acceleration and deceleration? Seconds. How long is my motor going to take to get from 0? And how long is my motor going to take if I already have a nominal speed, a commanded speed? So I'm going to look here in my manual, the parameter that I need. And I recommend that you look for it this way. Accel, which stands for acceleration. Okay, so let's look for this. 0, 1, 12. Here we go. So by default, we have 10 seconds in acceleration. This is time. Time, guys, okay? These are seconds, so this is deceleration time. It's 10 seconds by default, okay? Now, let's analyze and enter a new data to our deceleration time and acceleration time, okay? So, here, I'm going to power on my camera. And here we go. So that we can see our motor motion, or movement. So I have this under control here at 60 Hertz. This is the max frequency. And we're going to be checking what is going to be, or what is our movement, our motion that it does. So I'm going to start this. Okay. So this takes 10 seconds in theory. And it did take a pretty long time to get to that speed. Okay. Now we're going to stop this. And now we're going to change its acceleration. Okay? To make it 12. It's set at 10 seconds, so we're going to cut that down by half. Okay? So here I went a little bit lower than I wanted to. So let's see here. Okay? Very well. Try not to decrease by 0 or to 0 because there's going to be current peaks. It's going to be surges. And there's going to be some sort of a flaw or an error or something. Okay? So we already have 5 seconds. We're going to analyze again 60 Hertz. We start it up. Was this quicker or slower? Now, when I break this, it's not going to listen to me, and that's what I wanted to show you guys. At least for deceleration time. Because deceleration is 10 seconds, but it's not going to break. It's not going to decelerate with a 10-second time. Because I have a way to stop this, which is goes to stop. Now, what does this mean? This means that it's going to basically stop it by inertia. And inertia was quick, really. It basically disabled all the voltage, all the internal voltage for the stator. And that's why time is quicker. So if I configure this as ramp to stop, then it's going to take a little longer. And we're going to respect for that time for a ramp. So for now, we're only going to play around with our acceleration. Now, once you're on the field, remember, you need to keep this as ramp to stop. Okay, and then you can modify. But it works exactly the same way. So we're going to change this to halfway, more or less 2.5. Actually, 2.5. Here we go. So it's already changed. So acceleration. So now help me tell if it's quicker or not. You see this? It was much, much quicker the time. So then this means that it is respecting this. So again, tip, don't try to decrease this as much. Don't take it to that much to the max. So 2.5 is still pretty quick. But if you pull it down to 0, it can cause a surge, a current surge. And that's going to trip off the alarm. So you guys start measuring your acceleration time. 1 second? All right, that's feasible. It all depends on your load, okay? So guys, be very careful with this. Now, later on, we're going to see what auto-tuning is, okay? But if you guys want to carry a little bit of a load for your work, give it some time. Give it some limitations because you can help the motor moving that heavy load. Okay? So that's a different trick. Aside from auto-tuning. Because I also want you to test out acceleration. Okay? And so basically we're done with this topic at least. I told you guys it was pretty easy, so I'll see you guys in our next video.